All right, the last part of our test is going to be dealing with inverse functions. Remember this function right here, inverse means to switch x and y. Quick thing on there, remember that inverses are reflections over the diagonal line y equals x. So always think about that as you're getting an inverse function. Let's begin. We'll start with tables. With inverse functions, you got to be careful with the notation. When it says h of 0, if you do not see that -1, then you got to treat that 0 as an x. So if I go over here to my x row and go down to the h row, my output for that is going to be 3. So there is no work to do on that. You find the output for the h row from the x value of 0. When you go over here, you're not only going to be plugging in a number, but because of that -1, that's going to actually be a y. So be careful on that. That's an inverse, okay? It doesn't mean make the sign negative. It means switch the x and the y. Because I'm using the letter P, I want to start with this -4. And I want to go up to and report what my x value is when I plug in that y. So when I plug in -4 into the P function, my output for x is going to be -1. Finally, on the last one, it's just a combination of a couple. So in this case here, that's going to be that inverse function. So that's going to be a y value. Over here, there is no inverse function, so that's going to be an x. So we start with the y value of 5 for the h function. So you go over here. There's the y value 5. My x value output is going to be 3. Here, I'm going to look for the x value of -8 since there is no inverse. That's here. And I'm going to report the P line down there. And in this case here, it looks like it's just 3 plus 3, which is going to be 6. Number 21 is essentially the same type of problem. It's just a little bit more complex with the 4 out front, but definitely in a similar style. So when I want to evaluate f inverse, again, that's inverse. So I'll write inverse on that. That's going to be a y value. This is going to be 4f of 3. No inverse, so 3 is just an x. So the way you want to treat that is you want to look at the y value of 6, report the x value. So f inverse of 6 is going to be 4. Ignore the -4 for a minute. F of 3 is simply going to be when I plug in 3, what's my output? That's 2. So now what I'm going to do is I'm going to plug in 4 for the f inverse 6. And then we have this -4 here times f of 3. That -4, that basically is going to get distributed into the 2. So 4 minus 4 times 2. 4 minus 4 times 2. This is 2. This is 4. So that's going to be 4 minus 8. You can verify that using calculator work. 4 minus 8 is going to be -4. For 22, for the function g of x equals x squared plus 3, evaluate g inverse of 67, which means 67 is now a y value. The way I do this problem, in my opinion, the quickest way is to just plug that in for g of x. So now 67 will be x squared plus 3. From there, you're going to solve that for x. Take away the 3 from both sides. 67 minus 3, 64. To undo an x squared, we take the square root. But make sure you have a plus or minus. Always have a positive and negative square root. The square root of 64 is 8, so x is going to be plus or minus 8. Plug that in to verify your solutions. Remember to do square root. You can go down here and pick the square root function, or you can simply type SQRT. So if I square root 64. Remember, a calculator will only give you the positive square root. So when you're going through that and you're plugging in 8, oh my goodness, you will get, assuming I can type this in correctly, 67. But you can also get that by plugging in -8. So don't skip out on your plus or minus. Both give you the same answer here, so you have to have both in your solution. Okay, next question. So plus or minus 8 is your answer. All right, 23 is writing an inverse function. There are 4 steps to this. First step is to call the f of x y. So let's go ahead and just cross out the f of x and say y. The next step is to switch the x and y. So step 1, here, let me pause and write the steps out. All right, the steps are call f of x, y, switch x and y, solve for y, or then change y to f inverse x notation. Here we go. So we're going to write x equals y minus 3 over 5. Step 3, solve. In this case, I don't want that fraction there, so I'm going to multiply both sides by 5. That's going to cancel out those 5s. 5x equals y minus 3. We want to get y by itself, so we're going to add 3 to both sides. 5x plus 3 is simply 5x plus 3. And my final answer will be f inverse x equals 5x plus 3. Lots of different inverse type functions you can solve. That's just one example. Question number 24. This is, if you're standard, you can skip that. This is honors only. But if you're standard, you're welcome to look at the solving part and see how that works, because it's definitely doable for anybody. All right, so we're going to follow the same steps as before. We're going to call that y. Again, pause this and try it on your own. And I'm going to do x equals 2y minus 4 over y plus 6. All right, first step is to multiply that y plus 6 up with the x. So it's going to be x parentheses y plus 6 is equal to 2y minus 4. Next, we're going to distribute that x in. I'm not going to change colors because it takes so much time on the video, so it's just going to be xy plus 6x. The next step is to rearrange. Get the y's over here and the x's over here. I'm going to just kind of do all that at once. So minus 2y, minus 2y, minus 6x, minus 6x. And so what's going to happen is those will not be there, those will not be there. And so as I rewrite that over here, it's going to look like xy minus 2y equals -4 minus 6x. And then finally, if I want to distribute that factor the y out, not distribute it, undistribute it, you're going to have y parentheses x minus 2 equal to, and I'm just going to leave that the way it is. You can switch them if you want. And once you've done that, you are set to just drop this back down underneath on the right side. So that'll cancel that out. And your final answer will be g inverse x, -4 minus 6x, or you could say -6x minus 4, I don't care, over x minus 2. Don't let that one scare you. It's definitely doable. Let's finish up this page and finish up the practice test. And doing some inverse with a graph, let's take a look. From the graphing point of view, if you see h of 1, that 1 is an x. H of 1 means when x is 1, this is the x-axis, so when x is 1, what is the y? Well, let's see. At 1, I only have one value here, and that coordinate is 1, 4. So h of 1 is 4. Now, when it says h inverse -2, that's inverse, so that's going to be a y. So I actually want to go to the y, and I want to go down to -2. Now, if I go over to my graph, there's only one point where y is -2, and that's going to be all the way over here, -2, -4. So when, -4, -2. So when y is -2, x value is -4. So therefore your answer for that one is -4. And the last question says, is the inverse of the h of x a function, yes or no? So if you look at the points, looks like I have a point there. Looks like we got a point there, there, and there. And in order for the inverse to be a function, you have to make sure that when you plug in the y values, you only get one x value. In the case here, if I plug in 1, I get 4. But if I plug in the y value of 4, you'll see that there's actually two outputs, two x values. That coordinate here at -3, 4 and 1, 4. So if you have repeating y values, that's not going to be the case. So it's not going to be a function because if you threw a horizontal line in there, it would hit multiple points. So the answer is going to be no. And you could say for a reason, there are repeating y values. Or you could say fails not the vertical line test, but because it's the inverse, fails the horizontal line test. And so that is the reason. Guys, I appreciate you watching this. I know that you're going to do fantastic on your test if you go back and retry these problems on your own without watching the video. Always check the video and the solution key to verify. Have a fantastic rest of your day.